Okay, so I mentioned this file which we are spitting out using the dataframe.to underscore CSV function is going to be located wherever the lab5 underscore probability.ipynb file is located. So I'm going to browse using Finder here, and this is the file I'm running, right? Lab5 underscore probability. It's located in this folder titled lab notebooks, and so in this same folder I need to find outcomes.csv, and this is it right here. You can open it up and it's going to look just like the data frame, right? This will correspond to the indexing in Excel. So I'll close it out. I'll be back here, and to read that same file into a data frame, you will do pd for pandas.read csv, meaning read underscore csv, and then you provide the name of the file as a string, and it automatically creates a data frame that looks exactly like this data frame. And so I run these two, and this is what we obtain, which looks exactly like this. So that's how to read and write to and from a CSV file respectively. So let's look at some more complicated probability calculations. And here we want to find out how to count the number of outcomes of rolling a die one time. So num list, you create a list from range going from 1, and it stops one short of 7, so it starts at 1, ends at 6, which are the 6 possible outcomes when you toss a die, right? And then we use the third tools to find the number of ways of choosing the number of ways of getting one outcome out of the 6 possibilities. So it's 6 combination 1, right? And this just lists out all of the outcomes, which is 1, 2, 3 through 6, right? Permutations will give the same thing. I just mentioned that here for completeness. And then total number of outcomes is printed as the length of this, and that is the parameter space, which is where we started at the beginning of the class, right? So this is the set of all possible outcomes, which by definition is the parameter space. Sample space, I should say. The code below illustrates how to compute the probabilities of all possible total values that you can get from rolling 2 dice. And you know that the outcome of rolling 2 dice is basically equivalent to asking you to roll 1 die 2 times, right? So what are all the possible outcomes? You could get 1 and 1, right? The lowest score possible. You could get 6 and 6 if you are particularly lucky, and then all sorts of combinations. So we want to figure all of them out here, meaning figure out the sample space and then compute the probabilities of getting all possible outcomes. So we start out with the num list. Again, it's still going from 1 to 6. And this is where we begin to specify the number of times we want the dice tossed. So here we want 2 dice. So we provide a second argument to this product function, and it says repeat equals to, meaning perform that event of tossing a die twice. And notice we use a product function now, not combination or permutation. And that product function, you can see it like AND, right? The AND operator. When you do probability of A and B, which is equivalent to what? Probability of A intersection B. It's basically the probability of A multiplied by probability of B. Another way of saying that is it is the product of the probabilities of A and B, and that's why the function is named product. And so we'll provide num list going from 1 to 6. We're going to repeat the tossing up the coin twice, and then we can print out the length, and this will figure out what the length is, and in this case is what? 36. Why? Because you have, from the first die, how many outcomes do you have? 6. So n1 is 6. Remember, in the fundamental principles of counting, which we talked about in class, the number of outcomes is n1 times n2 times n3 down to any number of n's. So in this case, it's n1 times n2, where both of them are 6. So 6 times 6, the total number of outcomes, which is 36. Now, we copy all of the outcomes, which could be 1 and 1, 1 and 2, 1 and 3. So you get 1 on the first die, and you get 1 through 6 on the second die. You get 2 on the first die, you get 1 through 6 on the second die, right? So 2 is kept constant, and so on until you get to 6, 6, right? Those are all the outcomes. So I want to take all of these and put it into an array. So that's what this does. It takes the list, converts it to an array, and then you can use the numpy array function, right? Numpy sum, and we are basically summing this array. The array actually looks like this. So it's 1 1 as the first item, 1 2 as the second item, and so on. So this is just printing it out with a comma, but this is what it looks like. So what I want to do is to sum it this way so that I know what I get when I run the two, when I roll the 2 dice. So if I get 1 and 1, then the sum is 2. So my outcome is 2. If I roll 6 and 6, my outcome is 12. So I need to be able to sum across. And summing across is equal to axis equals what? Remember, for numpy arrays, axis equals 0 means we're summing down the rows, right? And axis equals 1 means we're summing across the columns, and that's what we want here. So we need to use the numpy.sum and provide a second argument, axis equals 1, which is precisely what this is. So numpy.sum, the results array, which is this numpy array, and then axis equals 1, and then that gets us the sum outcomes. And we then put that into a pandas data frame, and you need to be able to do this. We already did it in the last lab, and you will continue to do it for the rest of the course. So it's pandas.dataframe, right? pd.dataframe, note the caps in the D and in the F, and then you provide a dictionary, and the number of items, the key value pairs in the dictionary specifies the number of columns your data frame will have. The keys will be the column headers as shown here, outcomes, sum outcomes, those are the keys. The values will be the items you want to be stored in the columns, and here I want this data stored in the columns, so I provide that, as the first argument, the result list. I provide that as the first value. For the second key, the value I provide is the sum outcomes, which I just calculated, and then this data frame is printed out, and this is what it looks like. And again, to print it out with this fancy black and white stuff that makes it look like a spreadsheet, just do df1 and make sure it's the last command in a cell. If you want more cells, use this plus and print out the cells. Good. So that's how we obtain these results. These are all the outcomes. You can get 1 and 1 and the sum is 2. You can get 2 and 1, the sum is 3. You can get 1 and 2, the sum is still 3. Right? So these sums could be repeated because there are different ways to get a sum of 5, for instance. It could be 2 and 3, it could be 3 and 2, it could be 1 and 4, and so on. So now we're going to use the group by functionality, which we talked about in pandas data frame. So we group the data frame by the sum outcome because we want to find the probabilities for each of the outcomes and disregard the specifics of how you got the outcome. Like I said, to get 5, 2 and 3, 1 and 4, and so on, we want to group all of those together and just care about the outcome, which is a number that is going to vary from what to what. What's the minimum outcome you can ever get is when you get 1 from both dice, all right? And the sum of 1 and 1 is 2. What's the maximum you can ever get? 6 and 6, right? And you sum it up, it's 12. So this sum outcomes goes from 2 to 12. I want to find the probabilities for all those outcomes, starting from 2, then 3, 4, 5, and so on. So we group the data frame by the sum of outputs, and we can use the describe functionality so you can see what you get. So these are the outcomes. It goes from 2 to 12 like we expect, and then it tells you the counts of each. So there is only one way to get a sum of 2. It's by getting 1 and 1 from both dice. There are 2 ways to get a sum of 3. It's 1 and 2, and then 2 and 1, right? Because the 2 dice are independent. How about 4? There are 3 ways. It's 2 and 2, 1 and 3, and 3 and 1, and so on. So that's what these gets you. And you will say we need this. Now, we grab the count from this group by data frame. So we grouped it by the sum of outcomes, and we store it into this variable. Now we're going to call this variable and want to get this column titled count. And the way we get that is shown here by sum outcomes.count. And now we have these counts, and we store those into a data frame called outcome. By default, it's a data frame because this is a data frame. And so we print it out to see what it looks like. That's it, is the outcomes. And of course, we have the sum of outcomes as the index because that's the default behavior when you group by. So now those outcomes, which are these outcomes, we want to store them into an array. So we can do calculations on the array. And remember, we use NumPy for calculations on arrays. So how do you get an array out of a data frame? I mentioned that before. You use the dot values function. And it's actually, it's not like a typical function that expects an argument. You just call the values, and if you stop here, all you have is a 2-dimensional array of this information. But we want just this second column, right? Actually, this second column is really the first column. Why? Because this is an index. I hope that's clear. So this is an index. This is the first column. So we use the outcome data frame dot values to convert these outcomes to arrays. And then what row do we want? What rows do we want? We want all of the rows, right? These are the rows. So we put colon here as the first argument, and then the second here for the column we want column 0, which is the first column. And so this basically takes 1 through 1 here and puts it into a NumPy array. Now, how do you calculate the corresponding probabilities? You already know the number of outcomes for each of these sums, right? Again, 2 is from rolling rolling a die and getting 1 from both coins. 12 is from rolling 2 dice and getting 6 from both of them, right? So what's the probability you get 2 when you roll 2 dice? What's the number of outcomes? 1 divided by the total number of outcomes, which we already counted before, right? And it was 36 from product. We use the product function. You remember that? Where is it? Right here. We use the product function, and it gave us this as 36 total number of outcomes, which is n. In the context of our lecture notes is n, and then k is what we just calculated here. So these are the k's. So take each k and divide it by the same n. So for the first one, the probability will be 1 divided by 36. For the second one, probability of getting a 3 from both dice, meaning the sum of the outcomes on both dice, the probability that it is 3 will be 2 over n, 2 over 36. Probability that the sum you get from both dice will be 4 is 3 divided by 36, and so on. And so that's what this calculation does. And this is the advantage of using NumPy array, because you can do element-wise division. That's what this is basically, because it takes each item in the outcomes and divides by the same 36. So another way to get a 36 is numpy dot sum, and then you sum up all these outcomes, right? Because number of outcomes of getting a 2, 3, 4 all the way to 12, this sum is equal to the 36. Now, new data frame, we're creating a new data frame to show the results we care about. Basically, the sum of the outcomes from both dice, the outcomes, the number of times, this is the K, the number of ways of getting a sum that is 2, the number of ways of getting a sum that is 3, the number of ways of getting a sum that is 12. So that's what is in this second column. And in the third column, we have these probabilities we calculated as each of these number of outcomes divided by 36. And so how do we create this data frame? Well, create it from a dictionary. Use the pandas data frame function. Key will be the column header, the data you want to sit in that column. So this is df1 sum outcomes unique. So where is df1? df1 was defined right here. Is this long list, but we want just the outcomes, some outcomes, and in this case the outcomes are still repeated, right? 1 1 is one outcome, or let's look at 1 3 is one outcome, which is different from 3 1, but they both give you the same sum. So we need to use a unique function on these to grab only the unique occurrences of each sum. So we basically do df1 square bracket in parentheses, square bracket in quotes, some outcomes to get us this column, but this column is so long because the values are repeated, and to only grab the unique ones we do dot unique, and that's why this is df1 some outcomes dot unique. So we grab only the unique ones, and that's what you see here. So it's 2 through 12, no repetition. What do you want in the second column? Column header, you want it to be outcomes, you provide it as the key. What are the data you want here? The outcomes we talked about here, which you already stored in this array, and then we provide it as the data. Probability as the third column header, and then these probabilities you calculated are stored in the columns. And this is what the result looks like. And the exercise for you is to repeat this process, but for 3 coins. Tell me what these probabilities will be. Basically create this table when you actually have 3 coins. No, did I say 3 coins? No, I meant 3 dice. So when you have 3 dice, each one going from 1 to 5, right? Can you get me the probabilities of all the possible outcomes? And that is it for lab 5. It's a short and easy one. See you in class on Thursday.